purpose of our experiment was to measure the heat of one flame.
To do so, we built a calorimeter. And so to build it, we used an apple juice can in the middle, and then on the outsides of it for insulation we used newspaper, and then we used tin foil to stop radiant energy from leaving. And then we also covered the inside with tin foil. Right now this is our modified calorimeter with the black on the inside. And then we used a retort stand clip to hold our water above the candle, and then straws to have airflow in the can so that the flame will stay lit.
After doing some trial runs with our original design, we decided to change the interior to black, and we thought that our hypothesis was that the black would decrease the amount of temperature change in the water. To our surprise, this was not correct, as we'll explain later. And we also, once we completed our transformation, we found some very interesting results.
Yeah, we found that it was completely opposite of what we originally thought. You can see here with the yellow that was our two constant trials with the tinfoil on the interior. And then these three are the three with the black interior. Now we had to do like 6 or 8 trials in order to get constant results, but once we figured out our issues of making sure that we didn't spill any wax or keep the candle at the same distance from the water, and keeping the time exact, then we got more consistent results.
So some of the things we made sure to do properly after we figured out we weren't doing them properly were to make sure that the distance between the water and the candle was always 5 centimeters. And we also made sure the water was at 24.5 degrees Celsius. As well, we only had 32.24 milliliters of water in our beaker.
And we made sure we always had the lid on, and we always measured the temperature of the water as soon as we blew out the candle. And we waited for the candle to harden a bit before we took it out of our calorimeter so we didn't spill any wax. So to understand why the black caused the heat to be so much higher than with just the tinfoil, we did some research and found that dark colors are not just absorbers of heat, they are better absorbers of light, which thereby means that they're better radiators of heat. So that makes sense with our results then, because the black color is a very high radiator of heat, explaining why our results were so high.
Our next step would be to try out a white interior, due to the fact that it would not, the research we found said that it wouldn't be a very good radiator of heat, and therefore it should be lower than what the tinfoil was originally producing.
And that way we can verify our results.